All right, welcome to Chapter 7, Section 4, called Scientific Notation. This is for IM1 or Integrated Math 1. So a couple things you'll see on your screen here. The first thing you should see is the due date for this assignment. I don't see it on the teacher preview, but you'll see it on your screen. Attempts are always unlimited attempts. You can come in and complete this assignment as many times as you would like. Number of questions, this particular assignment has 10 questions, so that's all that means. Grading policy is best score, so whichever attempt is the best one is the one you keep. Partial credit is enabled, meaning if you answer 1 of 10 questions, you get credit for 1 question. Down here it says once you start your homework, you have to finish it before working on anything else. So that means if I click start, down here at the bottom right corner, you will see Submit Assignment button. It doesn't appear on my screen, again, teacher preview, but it'll be on your screen. That means that from this point on, whether you've worked on anything at all, or if you have only worked on a couple of these problems, you click that button. It does 2 things. Number 1, it stops the program from locking you out of everything, just like that previous screen said. And number 2, it actually makes effect in the gradebook, meaning we get to see what you're doing, we as teachers. So just make sure you always click that button. It saves your place too, so once you get the green check mark on here, it's going to make sure that you kind of start back where you left off. It's not going to restart you completely. If you've typed something in here and you have not clicked check, that does not save. Make sure you click the check button and then the Submit Assignment button. On the side here, you can see there's explanation, example, and message center. Explanation tells you you're going to lose your question attempt because it's going to give you the solution to this question. So it's not going to give you the answer and then let you type it in. You're going to have to come in on another attempt and try again. Example gives you an example of this problem type. So it shows you exactly what to do here. You can close this and open another example if you want. It just keeps giving you other examples. You can also message your teacher directly from the screen. So when you reach out, we know where to help you because it attaches a picture of this problem. All right. So let's go ahead and take a look at these. So this is reviewing negative exponents really quick. So remember, negative exponents just tells us it's in the wrong place. It's not actually a negative number. What it means is it's a number smaller than 1. So remember, all numbers are under 1. All numbers are also being multiplied by 1. So every number is being multiplied by 1. Every number is being divided by 1. We can always kind of think of it that way. The negative exponent just tells me it shouldn't be on the top of the fraction. It should be in the numerator. It should be in the denominator. If it was in the denominator, it shouldn't be there. It should be in the numerator. So it just tells me to move it. That's all that means. So this 1 gets left behind, and I end up having 10 to the 5th. Sorry, it's not negative anymore. Once we move it down, now it's positive. It's in the correct spot. Ta-da! It's good to go. No more negative. This 1 is still there, but we don't need to write it anymore. So this is what they want us to do. They just want us to show that. It says evaluate, though. So they do actually want us to show what this would be. So in this case, we need to make sure that we're kind of scooting the decimal out. Since it's 5, or to the 5th power, we're going to end up with 5 zeros there. It's just kind of scooching out. And I think they kind of showed you that on here too when you were looking at this piece. So you can see this is to the 4th power, there's 4 zeros. So that's a kind of a cute way of thinking of that. You're moving it over 4 times. So 1, 2, 3, 4, 5. And they are going to want the commas in here. They do tend to give grief if you don't put the commas in there. So check. All right. So now this is scientific notation when we have 5 times 10 to the 4th power. So scientific notation is a number between 1 and 9. It's never going to be bigger than 1 and 9. What I mean is this number in front. There can be a decimal place, so it can actually be 9.9999999. That's fine. But this first number can't be bigger than 9. So there can be decimal place. That's perfectly fine. But the number here needs to be between 1 and 9. And then you have a base of 10 raised to a power. So it's a way of writing small and large numbers. That's really what scientific notation is for. So when we have a number and a positive exponent, this tells me it's a larger number. And by larger, I mean larger than 1. But 10, they tend to be much larger than 1. If it's a negative exponent, that's smaller than 1. We've already kind of talked about that over a couple of different videos here. So this is larger than 1. To make it larger, I'm going to need to move the decimal place to the right. That's how I'm going to make this a bigger number. If I moved it to the left, it'd be a small number. So I want to go 1, 2, 3, 4. Oh, and when you don't see a decimal place, it's right there after that number. It's there, but it's kind of invisible. So I have 1, 2, 3, 4 zeros, and I'm going to put my comma in here, so I end up with 50,000. And standard notation is just the regular number, 50,000. So we have scientific notation or standard notation. So this is just a way of moving the decimal. So if this was a negative, I would move it to the left because I want a smaller number. So it just kind of depends on the number they give you there. I think it might be positive numbers to start off with here, because that was the same one we had in class, was a positive number. All right, so now we have regular or standard notation, and they want us to put it into scientific notation. So we have 4, 7, 6, 8. This is a comma, not a decimal. So the decimal place would actually be right here at the end. And remember, I want to move this. So this was 5 times 10 to the 4th power, but it was really 50,000. So this decimal was actually moved 4 times to write it this way. So I want to do the same thing. I want to go to the end here, and I want to move it 1, 2, 3 times. And it's by chance 3 here, but I want to stop so there's a number in front. 8, we don't keep going. There needs to be a number in front here between 1 and 9. So I have 4.768, and it's always going to be times 10, but it's the exponent is what's going to change here. So I moved it 3 times. That is my exponent. It's going to be a positive exponent, even though, yes, I moved it to the left, but the positive tells me that it was a larger number to start with. That's the standard notation is a large number. So we want to make sure that we always write that correctly. And you can see when I click on that button, times 10 pops up. All they want me to do is type in this kind of coefficient at the beginning and then the exponent that I decided on. But the times 10 is not negotiable. That's always going to be times 10. All right. So now we have a negative exponent. So remember, this doesn't mean negative number. It means it's a small number. Negative exponents tell me that it actually would be on the bottom of a denominator, or the bottom of a fraction in the denominator, if I was looking at fractions, that's just part of a number, and it's less than 1. So I'm going to take this 5, here's my decimal point. Instead of moving to the right, which would make it a big number, I'm going to move it to the left. And you can also think of when you're taking it out of scientific notation, when we're looking at a number line, this is positive, this is negative, if we're just thinking of direction. So again, I have to be taking it out of scientific notation. If it's positive, I move right. If it's negative, I move left. When you're putting it into scientific notation, it's kind of backwards, because you're taking either a large number and making it look smaller, or taking a very small number and making it look a little larger. So I'm going to take this decimal point and I'm going to go 1, 2, 3, 4, 5, 6. So that's my new decimal place. All of these get filled in with zeros. And then make sure you put a 0 on the front too, because that's a proper way to write this. So we have 0.123455, and then 5. So you notice there's not 6 zeros when I move it this way, because the 5 actually takes the place of one of those pieces. So let's go ahead and check that. Perfect. Okay, so now we're going to take this small number and put it into scientific notation. So I want to move this, so it's going to be times 10. I'm going to fill in an exponent. I'm going to fill in the number, the coefficient here. So those are my 2 pieces, always. So I'm going to take this, and I want to move it back to the first non-zero number. So I want to go right past the first non-zero number. So I actually want to move it right there. I can place it there so I know this is where I'm moving. So I'm going to have 8.522. I already know that. Now I just need to say how many times. 1, 2, 3. So I moved it 3 times, and it's a small number. Now it looks like a large number, so it's kind of backwards. I need that to be -3 to show that it's a number smaller than 1. It's a fraction of a number. So we're going to have 522. Silly thing zooming out on me here. We're zooming in. All right, perfect. Continue. Okay, so an astronomer's infrared telescope is able to detect radiation with a wavelength of 6.21 times 10 to the negative 6 meters. Write this number in standard notation. So I have 6.21 times 10 to the negative 6. So it's negative. I'm going to pay attention. So I'm taking it out of scientific notation. So it's negative. I'm going to move my decimal to the left. So 6.21, I'm going to go 1, 2, 3, 4, 5, 6. Put a 0 on the front. 1, 2, 3, 4, 5. Again, the sixth number is this one. So I know if I'm moving to the left, I'm going to have zeros, and one of those will be the number that was like the first number placeholder there. So it's 0.12345,621 because I moved that decimal. It's no longer there. Now it's over here. So the diameter of Venus at its equator is approximately 12,100 kilometers. Write this number in scientific notation. So now I have 12,100. So again, I know where I want the decimal to be. I have to move back to the first non-zero number. So I have to go here. It is here, and I want to move it here. So I'm going to go 1, 2, 3, 4 times. So I'm moving this direction. So 1.21. And I can kind of figure that out ahead of time. I don't need to write the zeros. They can kind of drop off. They're non-essential numbers. Times 10, and I moved it 4 times, so it's going to be to the positive 4. Remember, it's backwards when I'm putting it into scientific notation. So I know I'm moving to the left, which is negative direction, but I'm putting it into scientific notation, so it's positive. It's kind of backwards from the direction I move. 1.21 times 10 to the 4th power. Check. Alrighty. So let's keep moving here. Okay, so we're going to do some multiplication of scientific notation here. And we practiced quite a bit of this same type of multiplication as we were doing exponents in the last section. Or actually, this, I think it was section 1 and section 2 of chapter 7 here. So when we're multiplying numbers with exponents, what we do first is we're going to multiply the bases. So we're going to go 5.3 times 7. So 5.3, because they don't give us a calculator here, so we'll do it off to the side. So we have 35, 36, 37. And I need to make sure that I have one decimal place here, so I need to move it back one. So it's 37.1. I'm going to have to fix that. I can't have a number bigger than 9 in the front here. So I'll fix that in a minute. And then I'm going to have times 10. I'll leave that in blue. So times 10, that's going to come down. But I do have to deal with the exponents. So it's the same base. They're both times 10. And I have negative 7 plus 4. So it's going to be negative 3, just like that. So you want to make sure that when you're doing this part that you're paying attention to the rules of the exponents we learned in the first couple of sections here. If you're having trouble with that right now, go back to those videos and rewatch them, because I know I did that kind of quick, but I spent a lot of time on those videos going over how to multiply and divide exponents. So definitely go back to those videos if you're not sure what just happened. So one thing we do want to do here is fix this decimal place. So I'm going to use a different color here because we need to move this back one. And remember, it's backwards when I'm moving into scientific notation. So I moved it one space. Oh, I didn't mean to put 2 decimals there. One space to the left into scientific notation. So that actually means plus 1 because it's still being put in. So times 10, now I have negative 3 plus 1, and that's negative 2. So make sure you have to fix this. It can't be 37, but 3 is okay. It can be any number between 1 and 9. It just can't be 0, and it can't be bigger than 9. Okay, so that's one of the basic rules there. It has to be a number between 1 and 9. So we have to fix it when that happens. So then we have negative 2. Check. All right. So we have light waves. Light travels at 1.8 times 10 to the 7th kilometers in 1 minute. How far does it travel in 8 minutes? Well, I just want to take this and multiply by 8. because I want to know if this is every minute, then I want to multiply by 8 to know how many it travels in 8 minutes. So I'm going to do 1.8 times 8, like that. And you could go 18 times 8 too, if that made it a little easier. But this is 8 plus 6 more is 14. And then I need to make sure I move this back 1 because there's 1 decimal here. So I have to move it back 1. So it's 14.4 times 10 to the 7th. That doesn't change right now, but it is going to change because I need to fix this. This is 14, that's bigger than 9. I need to move it back 1. So that means I'm going to add 1 more because I'm moving it into scientific notation. I know I'm going toward the negatives if I think about a number line, but when I'm putting it into scientific notation, it's backwards. When I'm taking it out of scientific notation, that's when we follow the number line direction to the t. So negative is negative, positive is positive. But when I'm putting it in, I'm thinking of it backwards. So it's 1.44 times 10 to the 8th power. 0.44 times 10 to the 8th power. Oops. 8. Sorry, I had to scooch over to get there. All right, continue. Okay, so now we're going to go over some of the division rules for exponents. So again, this was section 2. If you're not real familiar with the division rules for exponents, you need to go back and watch that video. So we are going to divide these pieces, 4.5 divided by 5. So you can go 4.5 divided by 5 like this. So if I think of 45, that could divide 9 times. This decimal comes straight up here, and I would have 45, and I would end up with 0 here. So it's just going to be 0.9. So 0.9 times 10, that's not going to change, but what is going to change is the exponent. So I have negative 7. When I divide the same base, I subtract the exponents. So it's going to be negative 7 minus 6, which is negative 13, like that. I do need to do one more piece here to fix it. This is a 0. I can't have it a 0. It has to be between 1 and 9. So I need to move this guy back. Remember, this is still putting it into scientific notation, so even though I'm moving toward the positives on a number line, I'm actually going to subtract 1 here. So I have 9 times 10 to the negative 14. 10 to the negative 14. Whoops. I did not hit over far enough there. Negative. I'm just hitting all kinds of buttons here. All right, check. Yay. All right, one more of these. We're almost there. So Galaxy A has 8 times 10 to the 7th stars. Galaxy B has 6 times 10 to the 7th. 6 times 10 to the 10 stars. Which galaxy has more stars? Then fill in the blank with a number written in standard notation. So what I want to do is figure out, number one, to compare these, they need to have the same base in order for me to compare them. So if I wanted to have the same base here, I'm going to write these down like this, then what I kind of want to do is bring this, either I could bring them both down to just regular numbers, standard numbers, and they do want it in standard notation. So I could just expand them. So I'd have 8, and I go 1, 2, 3, 4, 5, 6, 7. I have 1, 2, 3, 4, 5, 6, 7 zeros. So I have a lot of commas in here. So this is 80. Is that 80 million? Yeah. And then 6, I'm going to move 10 times. So I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 9, 10. So I'm going to have a lot of commas there as well. So this one's definitely a little bit bigger because we're going to have 0, 0, 0, 0, 0, 0, 0, 0, 0, comma, 60. So I had 3 groups of zeros here, and then this comes out front. So which one's bigger? Well, most definitely Galaxy B is bigger if I look at the standard notation there. I could have also moved this over so that it was 7. So I could have just taken 3 away. and then this would be a bigger number than 8. So if they're the same base, these aren't the same because 1, 7 was 10. So if they are the same, you can just compare the coefficients and just say which one's bigger there. So galaxy B is definitely bigger. It has more stars. And then we want to look at how many times bigger. So I'm going to actually go through and cancel some of this stuff out. So I'm going to go like this. I'm going to cancel out all these extra zeros. So it's 6,008. So I kind of want to know how many times does this go in to 60 or 6,000, which is not going to go in evenly. So let's see, that's going to be, if I divide by 2, I get 3,000. If I divide by 2, I get 4. If I divide by 2 again, so I could have divided by more than 2, it looks like. I get 1,500 and 2. So if I divide by 2 again, I get 750. So 750 times the size. So I could have also used a calculator and just done 6,000 divided by 8, and it should give me the same answer there. So I'm pretty sure, I hope that's what they're looking for there. Yeah, that's what they're looking for. So they just wanted us to reduce the fraction. And since it's galaxy B is bigger than galaxy A, that's why B is on top and A is on the bottom. If A was bigger, then it would be A on top and B on the bottom for that fraction. So just make sure you're paying attention to the direction there. All right, well, that was section 4. I will see you in section 5.